So now in this lecture, we shall learn that how we can design the beam to beam moment connection, sorry, the shear connections. So now let us say if we want to design this particular shear connection from that is from 360 UP 44.7 to same member that is 360 UP 44.7. So right now we're talking about this particular joint. So this particular joint is basically 45 joint number. So we can press Ctrl T option again on your keyboard. And in here, we do need to ensure that this joint output and this particular element output options are selected. So we can left click on OK. And in here, we can go to the element joint forces and frame. So in here, we do need to select the joint number 45 here. And after that, we do need to select the strength design load combinations. So we can select all of these strength design load combinations here. And in addition to that, press Ctrl key and then select the strength envelope also. So we can left click on apply multiple items filters. And in here, if we are checking the strength option here, we can just maximize that. Now we know that, this particular beam is connected with the shear. So there shall not be any kind of bending moment that is coming. So in here, we can see that all of these values are 0. So when we're talking about the strength design as an envelope, the maximum shear force that is coming is 32.5344. And that is coming in this particular case, that is 1.2 times dead load plus 1.5 times live load. So the maximum shear at the end that is coming is approximately 32.534 kilonewton. So we can go to the ramp connection software itself. And in here, we were talking about the beam to beam connection. So as of now, you can just delete these because we shall take this again as a new assignment. We can delete this also. This we have already designed. So we can go to the new option here. In here, we can select beam to support. So we can select beam to girder. Under the data option here, material, we can select the 3679.1 and 300 grade. Again, for this particular girder also, we can select 3679.1 and 300 grade. Yeah, we can left click on OK. Here we can select the beam sizes. So beam sizes, we very well know that is 360 UV 44.7. So we can select the 360 UB 44.7, and here also we can select 360 UB 44.7. We can left click on OK here. After that, under the loading option, we know that the shear that is coming, that is approximately 32.54 kilonewton. There's no as such axial forces here. If we see the maximum axial forces, that is hardly negligible. That is not even 1 kilonewton. And in the other direction also, it is there's no as such force. So we can design the connection for 32.54 kilonewton. So we can left click on OK here. So this is the connection. We can go to the design and assign. And in here, we can select the beam to girder option. So either we can proceed with angle plate, or we can proceed with this particular option, or we can proceed with website plate connection. We can assign website plate connection here because that is the simplest connection. That is the practical connection also for these kind of problem statements. Now by default, even if with 2 bolt, the design is passed, that is it is 0.31. So we can left click on results option here. Here we can see that the plate length is value is 140, but minimum is 176. So we can increase the plate length here. But before that, we can have a look through as to what exactly are the options that has been selected here. So let us say if we proceed with M16 also, then also it is safe in the design. And if we are talking about the vertical end distance and horizontal end distance, and this is basically the bolt pitch. So if we increase it to 100 mm, so automatically the distance increases. And if we increase it to, let us say, 50, and this also we can increase it to 50. So with that, if we see the parameters that are failing, the bolt pitch, that is the maximum value is 72. So we can decrease it to 70 mm, the bolt pitch. So we can have it as 70 mm. And after that, again the parameter that is failing is plate length. So plate length needs to be minimum 176. So we can increase it to, let us say, 60 here and 60 here. So now we can see that this is basically green in color. So we can say that all the parameters are like okay for us. So we can find all the green ticks here, and everything is okay and everything is safe. So that is, one aspect of designing this beam to beam connection. But before that, we can understand what exactly are the options that has been considered. Welding category is SP. If we select it as GP, then obviously, the color changes to yellow. And after that, the length of the beam, that we can change it to, we can say 6 meters. Clearance, beam to girder alignment, that is at the top. Top or bottom, it doesn't matter because both of the beams are like same in sizes. The connector plate, it should be like, if the bolt is of 16 mm, then it is recommended that we can proceed with minimum of 12 mm thickness. So if we proceed with that, then plate thickness, the maximum plate thickness is 11.68. So we don't need to decrease it. So we can have it as 10 mm here. And if we see the plate weld size, the plate weld size is minimum is 7.5. So plate welding thickness can be taken from the material of the plate. We do know that that is 3679.1 and 300 mm. That is the same as a material. Bolts is M16 grade 8.8. Pistons, bolt rows, bolt columns. So let us say if we increase it to 2, then obviously there shall be 2 number of bolts here, 4 number of bolts. We can decrease it to 2, that is 1. And this is also okay, and this we can increase it to 8 mm. So again, the parameter in which it is failing in the design is plate thickness only. So the maximum plate thickness is 9.49 according to this parameter calculation. So we can decrease the plate thickness to 8 mm. So now it is okay. And if we let us say check with M12 grade 8.8 volts, so then the ratio becomes quite high and the ratio becomes 0.9 also. And the parameter in which it is failing is to design at the bolt pitch and gauge. Rest, as per design, the bolt group shear design capacity, that is almost touching the required calculation. So we can, change the pitch and gauge and have it optimized. But for the conservative side, we can have M16 grade 8.8 also. So with that, I hope you can understand how we can design the shear to beam connections. And if we click on the results, the most important parameter that you do need to understand, or that is a basic information, is this particular parameter, that is checking of the bolt shear capacity. So this is the bolt group shear capacity, and if we click on the view formula, so this is the design capacity of the bolt group. So that is the standard calculation as per design guide 3 by Australian Steel Institute. And this is basically we can say the bolt group sectional modulus. So this is basically the B into D square by 6, the for calculation that we do when we are calculating the second moment of area. So with all of these calculations, this is basically the shear parameter, that is 0.62 into Fu, that is the strength of the bolt, and AC is basically the area of the bolt. So with all of these calculations, we can say that the bolt group shear capacity that is coming is approximately, we can say, is 67.98, and the requirement is only 32.54 of the load that is coming. So this is how we can calculate the bolt group shear capacity. This is the design capacity of website plate. Design capacity of supported member block shear also needs to be checked. Supported member bending also needs to be checked. Local stability and local capacities. And these are the detailing requirements which are as per the design guide 3 and we can say different clauses of AS 4100 2020. So I hope the picture is clear. But additionally, like some of the parameters that are not covered in the either the design guide 3 or either in the AS 4100, reference has been taken from the AISC 360, that is American standard for structural steel design. So I hope the problem is clear to you that how we can design these kind of beam to beam like shear connections.